Kate. The next presenter is Professor Tuan Nung. Professor Tuan is from Uni Melbourne, so he's also a well-known professor to all of us. Yeah.
Thank you, Lei. And again, congratulations to Professor Kate Nguyen. Of course, I got a privilege to work with Kate when she was at Melbourne. So I'm going to show some slides which actually, or some include some of the work we did together. Yeah. So thank you. This is a great opportunity. I want to thank Professor Tommy Chen, ANSHM, and to organize this LEHO, RMIT hosting this is really great and to catch up with friends, colleagues. So my talk is going to look at something a bit different. We are focusing on the productivity, which I think there's a huge problem we have in the whole country. The reason is because our government is committed to build 1.2 million homes over the next 5 years. That means every 2 minutes, we have to build a home. In Victoria, we need 800,000 houses over the next 10 years. And of course, that's a big number. How can we get there? Because if we keep doing the same way we are doing, we will never get there. You look at the figures last year. So we are actually 90,000 homes in short, because that means if we want to build 1.2 million homes, that equivalent about 240,000. And last year we did less than 160,000. So there's a huge shortfall to fill. And of course, the cost, as we know, it increased, especially over COVID, 40% increase in the material cost. And we look at all the statistics, looking at the approval, looking at the completion rate, it's all on the way down from 2015. So we have a huge problem. And I think fundamentally, as a nation, we have the productivity issues. And there's no surprise that the last week, the Treasurer, Jim Chalmers, mentioned this is the highest priority in the government to address the productivity issues. Because all the figures, again, there's many ways to quantify productivity. And you can see last 15 years is, again, we see all the trend is coming down. So let's say if we use the same input, investment, labors, we are getting less as the output. So with that, another challenge is about, of course, the net zero target. If we look at our construction building industry, it's about 1/3 of the whole nation emission. And we look at this is about 137 million tons per year. And we have to really get it down. And if we do that, I think we can get better in terms of electrifying the grid, so we can have less energy use as in buildings. But we still have to look at the embodied carbon, the material we use in our buildings and infrastructure. So there's a huge challenge in that front as well. So looking at the whole industry, I can characterize into four main challenges. And the first one is the delays and the cost overrun. It's almost 100% of the major project got into that increase in cost over time. And material, it's all on the way up. Even it's stabilized now, but it's still a lot of challenges. And the quality, the performance, which I think Kate mentioned about some of the cladding, but there's a bigger than that. There are a lot of issues about quality. And one of the probably the biggest issue is the shortage of skill. So over the next 5 years, 20% of the workforce in our construction industry will retire. And there's actually a lot less people, young people joining the workforce, and how we can get that shortfall about almost 100,000 people in our industry. So with that, we have to build more, of course, a lot more with less. Less people, less material, less emission. And how can we do that? Because if we do the same way we do, we will never get there. So I think the overall holistic approach we've been thinking, and many of you are working on that, is how we can actually get better in terms of we have Industry 4.0 as a kind of principle, but it's not easy. We have to look at digital technology. Is that any new material system we can use? But again, if you want to be more productive, we have to look at automation, offsite construction, which I've been working for many years. I think that can address some of the challenges. But the supply chain, we have a very fragmented supply chain. Yeah, many companies, basically a lot of the SME companies struggle at the moment. So let's look at the next 15 years, how we are going to go to 2040, what the industry will look like. Of course, we can see there are a lot of talk about digital twin, design automation, look at AI and machine learning for optimizing production. We look at low carbon materials. We look at 3D printing, optimizing. So which one will give us the best outcomes? The thing is, we probably have to cover, we have to basically work on all those fronts. And of that, we've been doing a lot of research and try to identify what can give us some good outcomes. Because if we can do well with those fronts, I think there's some big benefit from faster construction, reduction in the cost. So I will give you some example. Starting with the journey, we've been working on modular construction for the last 15 years. It's really to my heart. I'm so passionate about the industry. But I just want to give you a first example of how I started this journey. So this basically the first modular construction building in Australia, and I was so very fortunate to be part of. So that was 15 years ago. A building called Little Hero, actually very close to our building here. And the vision at that time set by the architects and on the Casalidis, he said, typically a building like this would take 2 years to build. Can we build 90% faster? And of course, everything else from the wastage, from traffic reduction. So very high ambitions at that time. And of course, we said, let's look at something differently. We look at how we design for manufacturing and assembly. And of course, starting with very simple concept, it's really a container type, but we have to do differently. How we can stack them together horizontally, of course, very typical studio apartment in Melbourne. Can be small, it is a bit low. But you can see how we can actually interlock them together on the plan. Very slow moving. Okay, yeah, hopefully it will be faster. So this really just to highlight this concept of customize different modules, but we can actually put them together in a floor and make it very much like a Lego block. And of course, vertically, it comes down to connection, how we can quickly put that on site. And of course, so basically, this is just the concept of how we design and how the final product. It was manufactured in a factory in Brooklyn, which is not far from the Melbourne CBD. But when we bring that to site, many people know typical Melbourne street is a very small lane, only just enough for the truck to get in. And of course, you can see the effort of putting all those 68 units together. And we did that in 9 days. That's really one of the best outcomes. We show that it can be done a lot faster. And after that project, of course, we were involved in setting up the big body prefab box, and then working with company like Hickory to change that model. We don't have to do everything in the factory. So that's the GAP system. It's a GAP semi-finished, but provide a lot better cost effective in delivering. Basically, there's a building, the tallest modular buildings, Colin House, 60 stories, was done in that way. So I think it was done, it was proved it can be done, but it's not cost effective. We can do a lot faster, but the cost per module is quite high. So we look at other system, which is another CRCP, which we look at the panel system. Panels is another way to break it down, our building structures, but we have to design that so we can be a lot more high performing from structural and energy and protection. So basically it's a multi-layers system, and all that can be designed for put together in a factory. And we also show it can be done a lot faster with about 30% time saving. And the first project was completed with Lendlease and CSR in Canberra. And just want to highlight how we actually look at productivity in this case, because again, we can do very quickly in the factory. But when we move to site, there's so many issues, tolerance on site, very different because each panel, basically the tolerance is about few millimeters. But in the construction site, it can be 20 millimeters, 30 millimeters. So how can we quickly detect which panels might not fit in? And using digital twin, of course, in this case, we look at combining the whole the photogrammetry plus LiDARs. So we have to scan the whole site and look at how we get the data quickly to inform the crane operator and the installation team to match and to see any issues. Because I remember the first few panels took probably about more than an hour to install. But after we use this, basically it comes down to less than 10 minutes. So it's about six-fold improvement in terms of productivity. I think that's quite a good outcome. So after that project, we move on to look at how can we work in the whole industry, and that's how this Building 4.0 CRC was established. And of course, the main focus is to look at how digital technology can be adopted. We look at the history of how long it took the computer science to develop many different from the 1997, the IBM Deep Blue, up to the point that we can see everything start to jump with after the large language model. But in our industry, it's not that easy. When we started the CRC, we tried to map out what we can do better, starting from the planning and design. So you see we can do a lot better with the design. I think there's some video could run, but basically using generative AI, we can quickly generate so many design options, optimize them, and come up with a better solutions. So we started with just a typical computational and parametric design. The facade system, as I mentioned before, it might take a long time to optimize, but with this parametric model, we can quickly change and design that better. And this good project to highlight what we did differently. I hope the video can run. Okay, yes. So again, this is the project. We aim to like almost 90% automate the design process, working with a partner. Of course, these are modular buildings, but using steel structures. We try to look at the typical design process. It might take a few months, but can we do all that in probably less than half a day? We even automatically check the compliance, look at the connection and optimize them, looking at the even structural and design calculation. We actually can automate about 90% of those steps. Of course, it can be done, but how it can be practical in the design office is another question. But I think that the technology can get us there. Another project is look at the material part, which I got opportunity to work with a company to use the rubber waste in making barriers, road barrier. Because the good thing with rubbers, again, is there's a video here showing we can get a lot ductility out of the rubberized concrete. And then when we put together and make a barriers, I think we can See, this is the rubberized barriers which pass all the standards. And we are very fortunate that after the successful test, the barriers now been used in some of the major projects in Victoria. But the question is how we can accelerate the design of the material, because we want to have a low cost, low carbon mixes. And it took us probably about 2 years to try many different mixes. Can we use AI? Can we use some data, machine learning to get the data from the past work and accelerate the whole design process? And this is a paper came out of some of the previous study we did. Try to optimize from many different database from existing or previous study, but also using our data and give us the optimum mix. If we want to optimize the cost, if we want to optimize the carbon emission, we can get all that. And that probably from the AI and machine learning database we can do that in maybe just a couple of minutes. Probably I'm running out of time, but quickly show you another aspect of productivity, because safety, construction safety is again a big issue if you want to address the productivity. Because if the injury rate, construction is the top in compared to other industry, how can we actually come up with the system to really reduce all the work we need to address the safety? So this is our lab in our university, and we use this AI safety tool to be able to detect different behaviors, different requirements when it comes to safety to a particular machine. And that also lead to detecting cracks, which I think Young Zhou presented earlier. So we also look at how in real life we can get a lot of drone images. Can we quickly turn that into the quantification of damage in bridges or buildings? Again, that's going to come a lot more in the future. The last one I just want to show you is about productivity, but for infrastructure project. Because using AI and computer vision, which we did, in this case, working with level crossing authority, we show that at the moment, using a manual-based productivity is very much a very time-consuming, very unreliable. So using AI and machine learning, we can actually digitize and also automate a lot of the process. So with the project, we got a permission to set up a series of camera and working with a software company to use the AI algorithm to automate the monitoring of the whole project in along the Dublin Road. So 4 cameras was installed. We look at different location, and we look at how we can actually use our algorithm to really pick up human activities, machine activities, how many panels we install, and that can be done fully automatically. So I think that's again showing the potential, showing what we can do better in addressing the productivity. And the site manager can get all those information in just a very simple dashboard like this. And that's again require industry, government, and university working all together. So with that, I'd like to finish my talk, and thank you very much.
Tuan, good to see you after a while. The problem I can see is that in our industry, construction industry, we need a huge change of culture. Everything is hard, everything is dragged. We can do all this wonderful work which you have done. I'm very proud of your efforts and your colleagues. But how do we actually change the culture? Because, for example, in Sydney, there was supposed to be a strike by the train drivers, but they said the metro, which has no driver, there is no problems. There is no strike. because there is no one to strike. What I'm trying to say is that without putting people out of jobs, somehow we need to incentivize. There's no incentive. They just take the job and take it for in fact, incentive for them is to delay it. The more they delay, the more money they make. So somehow we need to, with the help of your last slide was the best, bring the three parties together, but we really need to seriously, otherwise it stays as a hypothetical. How do we incentivize the industry to finish early, like road construction? You say the estimated time of completion is 6 months, but for every week you finish early, you get a bonus. What's your thoughts on that one, briefly?
Excellent question again, Vision. I know all your knowledge and experience. I think as I said, the whole productivity challenge can't be solved with technology. It's really a complex issue, and I think it's probably more about human than technology. I just showed that a lot of new technology. We show it can be done, but why it hasn't been adopted? And coming back to you, because of the culture in our industry, risk averse. People don't want to take any risks. If you try and strip the risks to sub and sub and sub, and of course, people who are working on site have no incentive, and why they have to use something new because they might lose their job or something like that. That communication need to be very clear. And of course, if the system, of course, there's a tool empowering people, they can do better job, they can be less stressed. And of course, if there's incentive mechanism to really give bonus on, because the productivity is a good bonus they can have, they can do quicker, they can be safer, and that lead to better pay, or at least the mechanism to get it recognized. I think that's have to be done. But I have to say the challenge we had in the level crossing project, even the first day when we came to the site with some new cameras, and the union immediately asked, what are you going to do? How we can address the privacy? How we can make sure no one will be consider like penalized by doing this? And that took a lot of time to communicate that message. And of course, the first try was done, but how can we roll it out? So I think that there's still a lot of challenges we have to solve. And culture, again, is probably, to me, is probably the biggest barriers. Yeah. Thank you. Yeah.
One, hopefully.
Not working? Oh, thank you so much, Professor Tuan, for your very impressive work. So I just got a quick question, because you demonstrated lots of the very, I think, maybe the earliest or some sample offset projects in Australia, very impressive. But from my observation, we also see the industry is very conservative, especially for some small and medium enterprises. And then my question is that, from your perspective, how can we maybe making sure those very successful projects, the lessons and experience learned from those projects can be shared with the whole, across the whole industry? Because some companies, they say, I haven't done any offsite, and then the people's fears, any risks and failures. Another thing is that because when you are doing, for example, the automated compliance checking or AI-based design, so it's pretty much based on rules. But also the question relating to that, do you think maybe the knowledge and the lessons can also be kind of employed used by AI to better improve and optimize the new offset design? Thank you.
Excellent question. I'm very glad that you asked the question, because I have to say, involving in the prefab modular construction industry for the last 15 years, I get all the same question. People came to us asking, can I try this? And it's going back to a lot of people have tried that and failed. Of course, we we told people, don't do this, it's not going to work. But that lesson learned has been captured well. Even we have done our best, try to really provide the case studies and what people should do. But really, that information is not well communicated to many SMEs. And I have to say, if they keep doing that, there will be a lot of investment loss. Over the world, if you look at many modular construction company, there's huge problem in UK at the moment. Companies invested a lot of money and basically went bankrupt. Same in US. It might happen in Australia, but I think, fortunately, I think we haven't seen a really big failure yet. But there are a lot of companies tried and was not success. But going back to what AI can do to capture those lessons learned, I think it can be done. It just really haven't got any kind of platform and people can tap into and actually quickly learn this is not going to work or something, this is a direction. So it really needs a coordinated effort. And of course, ANSHM, I think we are in a good position because we got industry, we got government. If we can actually capture those lessons learned, I think that's a really good thing to do.